Alright, so we're going to take a look at lab number, I've already forgotten the number, but I'll find it here, 39. And the nice thing about Falstad is some circuits are kind of almost pre-built for you, and I always take one that's at least similar and rob it if I can. So this is an inverting amplifier. So I'm going to go up here to circuits, and I'm going to go to op amps, and I'm going to look, and under amplifiers is an inverting amplifier. Now you notice it's got positive 12 and negative 12, and normally on the breadboard we'd connect the negative 12 to negative and positive 12, but on Falstad this is inherently already done for you, so that's nice. And if you also notice, there's a 10K coming off the source on your drawing. We got a 1K here, so I'm going to edit it to be a 10K. And then the one that's feeding back from the output back to the negative is also a 10K. So I'm going to edit it as well. So we're stealing, whoops, I made it 10 ohms, which would not work very well. So let's try that one more time with the K. There we go. And I'm going to speed up the simulation speed so we can get a full output out of both. And you notice it's already giving me the scopes. Now the one thing I didn't do is change this 1 volt peak to peak and 500 hertz. So let's do that. So I should have fixed that first, and that's what you got to watch out for when you're stealing these, that you're getting everything to a T. So now let's speed up that simulation speed and let's see what we've got. And obviously we've got about a 1 millivolt input and about a 1 volt input and about a 1 volt output. And if you notice, these resistors are matched here, and let's speed up the simulation. Remember, we can modify these scopes. We want to change I'll go to 1 millisecond per division here. Do the same for this one. And 5, 1, there we go. And we can see the source here, AC source it says, and this is our output here. So this is the one marked out. So we've got pretty much a matched signal. Now our volts per division on the two scopes are different, which is okay. That just means we've got this one set to a different volts per division. So I don't think we can change that. I think it defaults to that, but that's okay as long as we're looking at the output. That is all that matters. We can do max, where is it? Remember, there was something that would change that a little bit. We can change time really easily up here. We have to kind of get a little wonky with it, but I can't remember what the other was. I think it was show max or something. Let's try max scale. Yeah, so we can do the same thing on here, and oops, I keep wanting to go to properties instead of just saying max scale. There we go. So now they're matched, and they're still 1 volt. More or less, but if you like seeing them equal, we did get it there. So what you're going to do, according to your table, is after you do the first little bit, is you're going to begin modifying your resistor values here, and that should change the properties of this circuit. So you've got to swap the R, looks like F in my drawings. Pretty tiny, but that is the one that feeds back from the output up here. So I'm not going to give you the answer to the next one. We'll make you do it on your own, but I am going to put a 20K there. So the one you'll be putting is a 27K. Make sure you put your K or put in 20. And notice what happened. Still about a volt here, but about 2 volts here. I'm going to stack these scopes and just want to see. I keep wanting to do properties, right click and say stack. There we go. And if you notice, it is inverting because our signals are out of phase, 180 degrees. So this is amplifying and it is inverting, thus the name of inverting amplifier. So anyway, that's where we can steal one. We could have built this from scratch. Could have put an op-amp in, a source, and a couple of resistors and an out and the ground. But why do that when you can rob one that's potentially pre-existing to use for your advantage? Now do take note of that IC. It's an 8-pin IC, so when you see this, it's not going to be a triangle. This is the symbol that you would see. but this is the schematic representation that you're seeing here. So, all right. Any questions, as always, just ask.